All right, guys. So you need to have your notes from the last 2 days out. We're going to actually do those application problems. So I'm going to scoot down to where we finished today. All right, so I'm going to do the application problems 1, 2, 3, and 4 that are on the front of that last page from the notes. Okay, so these are basically just word problems doing what we've been doing. So it's really not going to be that hard, I don't think. As long as you guys have been understanding what we're doing in class, it's just applying that. So this first one, it says, let X be the number of trees that Paula might plant per acre in her new section of orchard, and let Y of X represent the predicted average yield in peaches per acre. The formula for that function is represented by Y of X equals 960X minus 12X squared. Write and solve an inequality to express the requirement that for the new section, the average yield of peaches per acre should be at least 18,900 peaches. All right, so this word down here, this at least that we see right here, that is telling you if you have to have at least something, that's like a minimum value, right? So we know that whatever we do here, it's going to need to be greater than or equal to 18,900. Okay, so they gave us this formula right here. Y of X is representing the yield. It's how many peaches the trees are going to produce. So I know that I need that number needs to be greater than or equal to 18,900. So I'm going to go ahead and rewrite this. And if you're okay with it, I'm going to rewrite this as negative 12x squared plus 960x is greater than or equal to 18,900. I just went ahead and rewrote this with my x squared coming first. Okay, so same thing. Doesn't this look like what we've been doing in class? What we need to do is move this 18,900 over to the other side. So when you move it to the left, it's going to become minus 18,900 greater than or equal to 0. Okay, so what we want to do from here is see if there is anything that we could factor out. The first thing I see is that there's a leading coefficient of negative 12. So I'm going to see, are all three of those terms divisible by negative 12? And if they are, I'm just going to factor that negative 12 out. Okay, so take a second on your own, pause the video right now, and try to see if they're divisible by negative 12. All right, hopefully you guys saw that they were. All right, so if you factored a negative 12 out, you would get negative 12 times x squared minus 80x plus 1,577. And I'm going to go ahead and just set this equal to 0. Because I know that I need to figure out the solution. So I'm going to try to factor. Okay, so I need, this is a big number, right? I need factors of 1,577 that could add to give me negative 80. Based on my signs, I know if I'm multiplying to get a positive and adding to get a negative, I know that both signs need to be negative. So take a second, use your calculator, and just kind of start dividing. Divide by 2, obviously it's not going to work. Divide by 3, 4, and just keep going up the ladder. If we're adding to get negative 80, I know the numbers are going to need to be kind of big, okay? So pause the video for me and just start seeing if you can figure out factors of 1,577 that add to give you negative 80. All right, hopefully after some work here, you guys should have gotten x minus 35 minus x minus 45. So 35 times 45 should give you 1,577, and that would add to give you negative 80. Okay, so these are where I can take solutions. If I set x minus 35 equal to 0, I get x equals 35, and if I set x minus 45 equal to 0, I'm going to get that x equals 45. All right, so what I'm going to do then is put these on a number line, right? 35, 45. We're greater than or equal, so I know these would be shaded circles here. Okay, so I'm going to pick a test point. Okay, I like to pick 0, so I'm going to come over here. I know 0 is going to be somewhere over here, right? So when I test x equals 0, if I plug that into this very or not the very top, but this equation up here, don't we know that when we plug this in, negative 12 times 0 and plus 960 times 0, those just go away. And what it leaves me with is negative 18,900 is greater than or equal to 0. Is that true? No, that's false. So I am not going to be shading over here where 0 is. So that means that I'm going to actually shade here in the middle, right? Okay, so that's my solution. So basically what we're saying is that in order for Paula to yield the correct number of peaches, she's going to need to plant between 35 and 45 trees, right? All right, so you guys had to write your answer in inequality notation. So 35 is less than or equal to x is less than or equal to 45. Then you had to do interval notation, bracket 35, comma 45, bracket. And then it said to interpret this. Well, I just kind of did that for you. We're talking about yields of peaches. So we can say Paula must plant between 35 and 45. And I'm going to use the word inclusive here because each of those would work, right? 35 and 45 trees to yield at least, because that's the minimum amount, right? At least 18,900 peaches. Okay, so this would be all of your solution right here. Okay, so if you need to pause and go back, do so. Next one. Phoebe's Pecan Palace hosts the yearly Pecan Festival in Sumter County, Georgia. The pecans at the festival are spectacular. The production of pecans per acre for Phoebe's pecan trees can be modeled by the function P of x equals negative 20x squared plus 780x, where x represents the number of trees planted. If Phoebe needs to grow more than 7,360 pecans for the festival, how many trees should she plant? More than. That's not greater than or equal to. That's just more than. I know that however many she needs, the number of pecans that she's going to get needs to be greater than 7,360, right? So I could go ahead and set this up. I know negative 20x squared plus 780x needs to be greater than 7,360. So this now looks just like what you've been doing. So you're being given the original function and you're having to figure out the portion of the inequality that you would need to add there. All right, so to solve this, I'm going to move this 7,360 to the left, which will make it a negative, greater than 0. Okay, I have a leading coefficient of 20. So again, when I see that negative 20 in the front, that coefficient, I'm going to try to factor it out. All right, remember, you guys, today in class, we said you could go through and divide by negative 20 everywhere, and that would be fine, but you just need to remember, if you were to go through and divide each of these terms by negative 20, and when you get over here to this right side, inequalities, when you divide or multiply by a negative, the inequality sign needs to flip. So make sure if you're going through and dividing by negative 20, you flip that inequality sign. All right, I'm just going to factor it out. I get negative 20 times x squared minus 39x plus 368, and that is greater than 0. Okay, I now have this quadratic here that I can try to factor. Okay, if it doesn't factor, we know that we can always use the quadratic formula, but I'm going to try to factor because quadratic formula might be kind of difficult. So I'm going to see if I can factor. These numbers are a little bit larger than what we're used to dealing with, but you guys have calculators. So see if you can pause the video, find something that multiplies to give you 368 and adds to give you 39. Okay, so try to play around with some of these numbers that this might be divisible by, and they might be a little bit larger because we're adding to get negative 39. Okay, so pause and try that. All right, hopefully you guys came up with 16 and 23. So negative 16 times negative 23 adds to give you 378, or multiplies to give you 378, and it adds to give you that negative 39 in the middle. Okay, I went ahead and set it equal to 0 so that I could get my x values. I get a 16 and I get a positive 23. 16 and 23 are solutions to the quadratic. which means that if you graphed it, those are your x-intercepts, right? So I'm going to give myself a number line, 16, 23. These are greater than, so I'm going to have open circles because it's not greater than or equal to, it's just greater than. She just needs more than 7,360 pecans. So now remember we said we need a test point. I like to test 0, so 0 would be somewhere over here on the left. So I'm going to plug a 0 in, okay? So I'm testing x equals 0. So if I were to plug, I could go back to the factored form here, or I could just go back right here too. This would work. Because when I plug in a 0, I know that anywhere there's an x, those are just going to become zeros. So I end up with 0 plus 0 minus 7,360 is greater than 0. And is that true? No, that's false. So that is not a solution. So if I'm not shading on the left side, that means that I have to shade in the middle, because we remember what we said about quadratic inequalities. If you shade on the outside, you're going to skip a section, shade the next one. If you don't shade on the outside, you got to shade on the inside. So there's my solution, okay? So my solution set is between 16 and 23. So we've got 16 is less than x is less than 23. 16 comma 23. So we've got my inequality notation first, interval notation second, and then we want to interpret what it means. So she will need to plant between 16 and 23 trees. Okay, so there's your solution. So that is that second one. Pause it if you need to go back. Number 3. The path of a football kicked from the ground can be modeled by h equals negative 0.02x squared plus 1.2x, where x is the horizontal distance in yards from where the ball is kicked, and h is the corresponding height in yards. The crossbar on a field goal post is 10 feet above the ground. Okay, so if you don't know what that is, a field goal looks like this, right? And we kick the football through the field goal. So this is 10 feet high, right? So determine when the ball will be high enough to go over the crossbar. So if the ball is going to go over this crossbar, if this is exactly 10 feet, I need the ball to go higher than 10 feet, right? So if it's going over the crossbar, it's got to be greater than 10 feet. If it's equal to 10 feet, it's going to hit the crossbar, right? So I can model this by negative 0.02x squared plus 1.2x needs to be greater than 10, right? Because I need that football, which is this path right here, I need that to go higher than 10 feet. Okay, so I'm going to move my 10 over, negative 0.02x squared plus 1.2x minus 10 is greater than 0. Again, I have this negative 0.02 in the front out here. I'm going to see if I could factor that out of everything. You could divide everything by negative 0.02, but remember, if you divide by a negative, this inequality is going to have to flip, okay? I'm going to factor it out. I'm going to see if I can remove the 0.02, okay? Everything is divisible, right? So what I end up with is negative 0.02 times x squared minus 60x plus 500. It's greater than 0. Keep looking like sixes. There's a 0. All right, so then I want to try to factor if I can. Okay, so x multiplying to get a positive, adding to get a negative gives me a negative and a negative. I need factors of 500 that could add to give me negative 60. So take a minute, pause the video, try to figure out those factors. All right, hopefully 10 and 50 just jumped out at you when you started thinking about that. Okay, so I'm going to set this equal to 0 so that I can then say, okay, this is x equals 10, and this is x equals positive 50. X minus 10 equals 0, you solve it, you get a 10. X minus 50 equals 0, you solve it, you get positive 50. Okay, these are solutions to the quadratic inequality here, or just to the quadratic, really, not to the inequality yet. These are solutions to the quadratic. Those are x-intercepts. So I'm going to draw me a number line. 10 and 50. 10 is here. 50's here. We're not equal, because remember we said it couldn't be equal to 10, because if it was equal to 10, if the height of the football was equal to 10, it's not going over that crossbar. So I'm going to test 0. That's what I like to test, remember. So I'm going to test x equals 0, and I'm going to plug that into I'm going right here with it, okay? Because remember, when I plug in that 0, what I'm going to end up with, this is going to become a 0, this becomes a 0. I get 0 plus 0 minus 10 is greater than 0, and is that true? That's false, right? So I don't shade at 0, okay? We need a note there, don't shade at 0. So that means then I need to shade here in the middle. So there's your solution set, okay? So x has to be between 10, not negative 10, I'm sorry, I'm not real sure where that came from. X has to be between 10 and 50, right? 10, 50. So we've got our inequality notation and our interval notation. Okay? So the question is saying, determine when the ball will be high enough to go over the crossbar. All right, so we're answering this question, right? X is representing, all right, if we go back and we look right here, X is the horizontal distance in yards, right? All right, so horizontal distance is how far the ball has traveled. So how far is the ball going to need to travel before, or in order for it to go through that crossbar? When's it going to be at that height? So we would say the ball will be above 10 feet after it has traveled 10 yards, but before it reaches or it goes 50 yards, right? Because what's happening is, you got to think about this. This football is being kicked like this, and it's doing this, right? So there's a certain window where it's going to be above this 10-foot height, right? So it's at this time here and this time here that this football is going to make it through those crossbars, okay? So there's your solution there. So pause the video if you need to. Number 4, a paint can is dropped from the top of a 500-foot building being constructed. The height of the paint can can be modeled by h equals negative 16 t squared plus 500, where h is the height in feet and t is the time in seconds. A platform is 100 feet from the ground. Determine when the paint can is above the platform. Okay, so we got this building, right? Here's this building. So this building is 500 feet tall, right? All right, well, there's a platform here that's 100 feet tall. We're going to drop this paint can. I don't claim to be an artist, but this paint can is going to fall right down here. Kind of looks like a can, maybe. All right, so I want to know, when is the paint can above the platform? Okay, it's going to be above this platform when it is greater than 100 feet off the ground. Would you agree with that? And it's greater than, and it's not equal to, because if it's equal to 100 feet, it is on the platform. We want to know, when is it above the platform? Okay, so we've got negative 16 t squared plus 500 is greater than 100. So I could subtract 100, right? When I move this over here, it's going to be like minus 100, right? So that gives me negative 16 t squared plus 400 is greater than 0. I want to try to factor out negative 16. Well, that will factor out evenly. I get negative 16 times t squared minus 25 is greater than 0. All right, ding, 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 ding. Alarm's going off, right? T squared minus 25. That is a difference of squares, right? So that's going to factor into t plus 5, t minus 5. And I'm going to go ahead and set it equal to 0, because I can then take these factors and solve. Okay, so what I'm going to get here is t equals negative 5 and t equals positive 5. Okay, all right, so these are possible solutions. So I'm going to draw my number line. Negative 5, 5 were not equal, so they're open circles. I need a test point. 0's in the middle, that works, right? So I'm going to test I'm going to go ahead and just go back right here to test. So when I test t equals 0 and I plug that into this equation here, I'm going to get 0 plus 400 is greater than 0. Well, hey, that's true, right? So shade at 0. Okay, here it is right here. So I'm going to shade here. Okay, so my solution set, my solution set is -5 is less than x is less than 5. And in interval notation, it's 5, 5 with parentheses, right? All right, but we need to think for a second. We're talking about when a paint can is above the platform. And we're saying that this paint can is going to be above this platform. T is being measured. It's the time in seconds, right? So basically what we're saying is this can is going to be above the platform between -5 seconds and +5 seconds. Well, can you have negative time? No, we can't. So when I interpret this, what I'm going to say, because we can't have negative time, all right, because we can't have negative time, the paint can will be above the platform from 0 to 5 seconds. Okay, after that 5 seconds, it's going to be on the platform, right? So we have to take into consideration the fact that we can't have a negative time here. Okay, pause if you need to, go back, look at some of these again, but make sure you get these 4 finished, and don't forget to do your homework problems 1 through 7 on the front. See you tomorrow.